Hello, my name is Nicholas Lisko, and this is my video for FE Mechanics of Materials review. So for this video, I'm just going to run through a couple problems that I have seen not only in FE books, but also on some slides that I've done, just to get a better understanding of the problems. So this question right here says, what is most nearly the maximum compressive stress at section DD 1.5 meters from the left end? We're going to find the reaction at A, and then we'll find the bending moment at section DD. So we're going to start by finding the reaction for A, and we're going to do that by starting at point C. A times 4.5 total distance minus the 45 kilonewtons times 1.5 meters. So we can just plug that into our calculator and we get RA is equal to 15 kilonewtons. From here, we're going to want to find the bending moment at section DD. So that's right here, 1.5 meters from the left. And for that, we'll just do moment equals 15 kilonewtons times a 1.5, which will get us 45 kilonewtons. From here, we want to find the maximum compressive stress. And that formula is sigma max equals MC over I. So sigma max equals MC over I. I, because it's the inertia, because it's square, is going to be 1/12 BH cubed. C is the distance, the height divided by 2. So it'll be M times C over 2 over BH cubed. So we got to convert everything to meters because right here we're 10 centimeters. So this will be 0.1 meters. The moment is I think I messed something up. This is supposed to be 22.5. So the moment here will be 22.5 times 0.1 over 2. And then we're going to want to convert this to newtons, so we'll multiply it by 1,000 because we're in megapascals. And we'll divide that by 1/12. Base is 0.125 meters times 0.1 meters cubed, which will get us about 108 times 10 to the 6th pascals, or 110 MPa, which gives us answer B. So the next problem we'll be doing, we're going to find the max torque on a 0.065 meter diameter solid shaft. That is 8,200 newtons per meter. What is most nearly the maximum shear stress in the shaft? So for this, we can go to the FE handbook and look for some equations that we're going to use. On page 134, torsion. And that is just tau equals TR over J. It's a pretty simple problem. So for this, we're given the diameter, which is 0.065 meters. We got to get that to radius, so we just divide by 2, which equals 0.0325 meters. We're given T, which is 8,200 newtons per meter. And then we have to find J. J is equal to pi r to the 4th over 2. So we do pi times 0.0325 to the 4th over 2, which gets us 1.75 times 10 to the negative 6th meters to the 4th. So we just plug in what we've got now. So it's 8,200 times 0.0325 meters over 1.75 times 10 to the negative 6th, which gets us about 152 times 10 to the 6th pascals, or about 150 MPa. So the answer for this problem would be A. The next problem we're going to get into is a just principal stresses question. It's saying, what element is subjected to the plane stress condition shown? What is the max shear stress? So for this problem, we're able to go to page 132 that talks about stress and strain, and we have the sigma A and sigma B equation. So I'll just write that out real quick. So to fill this in, we're given sigma x equals negative 210 MPa, sigma y equals 115 MPa, and tau xy equals 150 MPa. So it's pretty straightforward and standard. 210, negative 210, plus 115 over 2, plus or minus, we got to get the two values, negative 210 minus 115 squared over 2, plus 150 squared. So from here, we'll get sigma x and sigma y, which will be, or sigma A, I guess, and sigma B, I mean, about 173.6 MPa, and negative 268.6 MPa. It's based off adding and subtracting. So we have to find the max shear stress, and to find that, we'll do tau max equals sigma A minus sigma B over 2. And that'll be 173.6 minus negative 268.6 over 2. Which will end up being about 221.15 MPa, or C, which is 220 MPa. I don't think I said where we can find the shear stress equation, but or shear max. The max shear equation is on page 134, right at the top of the page. along with sigma A, the principal stress equations on page 132. The next problem says, given a shear stress of tau xy equals 23 MPa and a shear modulus of G equals 110 MPa, the shear strain is most nearly what? So for this problem, we're going to use Hooke's law, which is gamma xy equals tau xy over G. And for this problem, we have two givens, tau xy and G, so it's pretty simple. This equation is found on page 134 in the book. We're just doing the x direction. This will be 23 MPa over 110 times 10 to the third GPa. Which will get us about 2.09 times 10 to the negative fourth radians, or about 2.1. It looks like I wrote down one of the answers wrong. It should be 2.1 times 10 to the negative fourth, but pretty simple problem, just some plug and chug, and we get 2.1 times 10 to the negative fourth radians. This right here is a pretty simple problem where we just have to find the max moment of this beam. The problem statement says, the shear diagram for a simply supported beam is shown. What is most nearly the maximum moment in this beam? So for this, both sides are even, so we could just take a moment from B and find it that way. So start with 52.5 times 2.3 meters. It's this first section, plus 1/2 of 120 minus 0.2 minus 52.5 times 2.3 plus that's to find the difference right here, the 120.2 minus 52.5. We'll do another 120 plus 120.2. That's 1/2 times 1.1 meters. So when we solve this, we get about 264.7 Newton meters. And that is most closely B, which is 260 newtons per Newton meters. So for this last problem, pretty simple beam problem, we're just going to be finding the reaction at C in the beam shown below. We've got a force of 15 kilonewtons acting on B, and then 5 kilonewtons per meter over here between C and D. For this problem, we can take a moment at A. We will find Cy because we don't have the force here, so we don't have the force here. But we have to find the reaction at C. So we'll do RCy, resultant force there, times 10 meters, that's from A, minus 15 times 5, because it's a force down, and then minus 5 times 5 times the center, which which is 12.5, away from A. So from here, we're able to gather that our CY, 10 RCY, is equal to this 45 plus 25 times 12.5. Let's type this into a calculator. So equals 357.5. Wait, 12.5. Oh, I see. 45. Wonder what I'm doing. 50, 75. Plus 30 gets us 387.5, 10 RCY. RCY equals 38.75. All the answers are upward. So we will go with D. 40 kilonewtons upward. Thanks for watching my video. I'm hoping this filming was all right. I hope you learned how to do a few new problems.